Pyramid, pyramid, what's your volume? Let's find out what it is. 1/3 times height times base area. That is what it is.
Hey guys, well that is what it is for volume of pyramids. Those little hand puppets, I remember doing those when I was younger. It's been a while. We're going to be finding these volumes of pyramids and using them in this lesson. And you'll see that that's exactly what we'll be doing with the 1/3 base and height, base area times height. That is the formula we'll be using. Before we get to there, let's do a little cartoon of our day. So here we go, and in the bleachers, we tape up sore ankles, we tape up sore wrists, we even tape up sore elbows. We do not, however, tape up sore throats. As the trainer was taping his throat there. Oh, can't talk. Alright, so here we go with page 339. It's the first page there you'll see in your lesson 11.6. And I just wanted to show you this just so you guys get the idea. So here's these two shapes here. It looks like a kind of a cube, and then our pyramid. Here's our pyramid. The heights are the same, it shows right here. The heights are the same. So the pyramid and the prism. So the pyramid, here's our prism. This would be like probably a cube, but it is a prism. And we learned that in the last lesson. They have the same height and the same square base. So this is the same square base. We have the same square base there. You can see how this one's kind of chopped up into 3 sections here. It says when the pyramid is filled with sand and poured into the prism, it takes 3 pyramids to fill the prism. So if we pour in 1 prism, it only goes up to that first block right there. Then we pour in a second one, it goes up to the second one. We pour in a 3rd prism then, and it fills our 3rd pyramid. It fills our prism all the way to the top. So it takes 3, basically the volume of 3 pyramids with the same base and the same height to fill up a prism with the same base area and the same height. So that's what we're going to see here with this volume formula here. So our core concept on 341, the volume of a pyramid is 1/3 times the base area times the height. So basically, if it takes 3 to fill it up, then that means that the air or the volume of what's inside the space inside the pyramid is 1/3 of what is inside this prism. And we know to find the volume of the prism, it's just base area times height. So we need to now multiply then, if it's a pyramid, we're going to multiply it by 1/3, base area times height. So we're still going to find the base area and the height, but we have to multiply it by 1/3 because of the fact that it's a pyramid and not a prism. Now here's another way you can write it down here. I usually just do this. Base area times height, we can divide it by 3. So we can multiply the base area times the height and then quickly just divide by 3. That makes it a little easier maybe than multiplying by 1/3. Alright, let's go ahead and try some of these. Okay, so on page 342, our extra practice begins 1 through 6. We're just finding the volume of the pyramids. And so we want to look for the base area of the pyramid and what that shape of the base is going to be. So sometimes the base will be a triangle like this one, and we got to remember the triangle formula, which is 1/2 base times height. And so here's the base and the height of just this triangular base. And then it shows this 9 centimeters right here. It goes right down to this right angle. That's kind of inside of the pyramid. That's going to be the height of the pyramid, how tall the pyramid is. So I know this one right here, don't get these confused. This one that's going to this side length right here is actually just the base. So you got to think of this triangle right here with these 2 dotted lines, and this side here is the base. And that then 4 centimeters is your height. And so that would be the base times the height here divided by 2 for just the base area. And then we multiply that by the 9 for the height, but then because it's a pyramid, we got to multiply by 1/3. Don't forget that. So we're going to use our formula 1/3 base area times height. So it's going to be volume is equal to 1/3 times our base area, which is going to be that triangle formula, 1/2 base times height, so 1/2 4 times 6 of our triangular base, times our height, which is the 9. And so now we can kind of just simplify the numbers inside of here, and we could say, oh, that's going to be 12 inside of here. So we can say 1/3 times 12 times 9. We could also quickly just do 1/3 and 9, because 3 goes into 9. You can do that real fast if you want to. or you could just multiply the 12 and 9 and get 108 and divide by 3. So either way, that's fine. So I could have said, 3 goes into 9 3 times. 12 times 3 is 36, or just 108 divided by 3 is 36. So it's 36 centimeters cubed. And don't forget, the units are cubed, again, because we're talking about volume. On this one here, you could see that's going to be our height right here. Again, the right angle part is going to be kind of in the center or inside of the pyramid. That's going to be always your height. Our base area here, the base is actually a square. You can see 6 inches this way, 6 inches this way, so it's a square base. So we're just going to use our volume formula, so it's going to be 1/3, again, starts with the 1/3. Base area is going to be 6 times 6, length times width for just this square base, or 6 squared, you can think of it as. So that's going to be 36 in there, times the height, which is 8. And so we can then multiply this all together. We can then get the 36 here times 8. If we want to do 36 times 8 and then divide by 3, that would be fine. Or you could quickly say 3 goes into 36 12 times, and then you're just doing 12 times 8. There's more than one way we can do this. I just multiplied these two together, got 288, and then divide by 3, and it's 96. And it's inches cubed. All right, let's go on to the next one. Okay, so for number 3 and 4, go ahead and pause the video and just try these two. And then once you're finished with these two, then go ahead and play the video so you can check your work. Okay, hopefully you've paused the video and you've done 3 and 4, and now you're just checking your answers. So for this one, again, we're just going to use the 1/3 base area. Our base is a square again, just like our last one. So we're going to just do 1/3 times 4, or 4 squared, and our height, you can see there is 9. There's that little right angle mark inside of that figure, and so it's times 9, so 4 times 4 is 16, and so now it's 1/3 times this. Again, you could say, cross cancel 3 and 9 if I want to. Now it's just 16 times 3, or we can multiply, get 144 divided by 3. Either way, our answer there is 48 yards cubed. So don't forget the cubic units. On the next one, it's a rectangular base. 11 and 7 are the dimensions, the length and the width of this base. Again, there's your height right down the center in the middle of this pyramid. 15 meters is the height. So it's going to be 1/3, and just length times width for a rectangular base, 11 times the 7 times the 15. So it's going to give us 77 in there for our base area. And if you want, again, you can say 3 goes into 15 5 times, and now it's just 5 times 77, or we can multiply these two and divide by 3. That's what I did here. 1155 divided by 3 gives us 385 meters cubed. All right, let's go on to next two. Okay, so 5 and 6, a little different. You have a pentagonal base. But they tell you what the base area is. You don't even have to find that, which we could have if they gave us like a radius or something. But they gave us the area of the base, and they also have a pyramid over here, but it's not a regular pyramid. You don't see the, your height is going to be this 6 right here. So it's kind of a slanted pyramid, but there's your height. That's where it's going to be at the right angle. So I'm going to let you try these two. Go ahead and try these two to try to find the volume of these two, and then go ahead and play the video again. So go ahead and stop the video. Do 5 and 6 and then play. Alright, so hopefully you've done 5 and 6 and you're just checking your answers now. So for this one, we're going to be saying volume is equal to 1/3. Start off with that 1/3. Base area is the 27, and then the height is 5. And you could again say 3 goes into 27 9 times, and just 9 times 5. Or you could be saying 27 times 5 is 135 divided by 3, so 45 centimeters cubed. That would be our answer on that one. And for this next one, we're going to say again, volume is equal to 1/3. Base area is just 4 times 1, and then the height is 6. So 4 times 1 will give us 4, and 4 times 6 is 24, and then we just do 24 divided by 3, which is 8 feet cubed. Again, you could say half of 6 is 2, and then you're just doing basically 4 times 2, 8 feet cubed for that one. All right, let's move on to our joke of the day. So if April showers bring Mayflowers, what do Mayflowers bring? Well, they bring pilgrims, because they came across on the Mayflower. Okay, on page 343, we're looking to find the indicated measure So number 7, it says a pyramid with a square base has a volume of 128 cubic inches. So it tells us the volume there, and a height of 6 inches. It tells us the height. What we don't know is we don't know what the area of the base is. So it says find the side length of the square base. So we want to know not just the area of the base, but what's the side length of that base. So we're going to still use our volume formula here because it's a pyramid. So when it says pyramid, we got to remember pyramid, we're talking about volume. So volume equals 1/3 base area times height. So we know what the volume is. That's 128. We can fill that in. We got the 1/3 there. The base area for this one, we just don't know what the side length is. So for a square base, it's always side squared. So if we say a side length is x, we're going to look, we're going to try to solve for x. We could say x squared, and we just need to now solve for x, and that will tell us a side length. And then we know the height. The height they tell us is 6. So we got to get the x squared by itself. So the first thing we could do here is we could maybe cross cancel the 3 and the 6 here just to simplify this. 3 goes into 6 2 times. Now it's 128 equals 2 times the x squared. We then can just divide by 2. And dividing 128 by 2, we get 64. And then we would just take the square root of both sides to solve for x and get rid of that square. So take the square root of both sides, and the square root of 64 is 8. So our side length would be 8 inches of this square base, and that's our answer. Number 8, another pyramid with a rectangular base has a volume of 6 cubic feet. So again, they tell us the volume. The length of the rectangular base is 3 feet. The width of the base is 1.5 feet. What's the height of the pyramid? So we're looking for the height. We're looking for this right here, so we can know what the base area is with the dimensions of length and width. So we're going to start off with using that formula. We know volume is 6. It says it right there, volume of 6 cubic feet. We're going to put the 1/3 there. Our base area, well, what's that base area going to be? It says the length of the rectangular base is 3 feet, and the width is 1.5. So it's really 3 times 1.5. So we could say 3 times 1.5 times h. And then the h is the one we don't know. And right there with 1/3 and 3, we can cross cancel those really quickly because 3 goes into 3 one time, of course. And so now all we have here is 6 is equal to 1.5h. So we can write that out. And then to solve for h, just divide by 1.5. 6 divided by 1.5, you could do it on a calculator, it's just 4. So it's 4 feet for the height. And then for number 9, again, we have another pyramid. It says pyramid with a triangular base has a volume of 18 cubic centimeters. So again, we know the volume on this one. We're going to plug that in there. The height of the pyramid is 9 centimeters. So we know the height. We're going to plug in 9 over here. And the height of the triangular base is 3 centimeters. So just the height of that base. So 9 is the height of the whole pyramid. That's this h. The 3 is the height of the base. That's going to be used inside for the base area. We're trying to find the width of the base. So now we need to remember, okay, if it's a triangular base, to find the area of that base, it's 1/2 base times height, or length times width, same thing. So we want to realize what we're going to use here. So using that volume formula, we know the volume is 18, so we're going to plug in 18 for that. We know we have to use the 1/3. Our base area here is going to be 1/2 times the height of that, which is 3, times the base. And the width of the base is what we're looking for. So we can use W, or we can use a little b to represent that. It doesn't matter. So basically either way. So I'm going to use W in this one. So 1/2 times the 3 times the W. That would be like this height of the triangular base times the width of the base. We still got to multiply it by the height, though. The height of the whole thing, it says, is 9. So we're going to have to plug in our 9 there. And what I'm doing, I'm going to cross cancel 3 and 9 just to start to get this a little simpler. So I can cross cancel 3 and 9. 3 goes into 9 3 times. And so now what we'll see is in here, we're going to have 1/2 times 3W times 3. Well, we know 3 times 3 here, that's going to give us 9W. And then 1/2 times 9W, we're just going to make it kind of like this, 9W over 2, because 1 times 9W is 9W, and then just 2 on the bottom. And 18 is equaling that. So now what we need to do is, we can multiply both sides, get rid of the fraction by multiplying both sides by 2 to get rid of this fraction. And so that's going to say 2 times 18 over here, giving us 36. The 2's here will cancel. So 36 is equal to 9W, and then just divide by our 9. 36 divided by 9 is 4, so the width of the base is 4 centimeters. Alright, so these are just where you're trying to find a particular measure, so you're trying to find something using still this volume formula. Because you're using the same thing, because it says volume, it says pyramid, this is the formula for volume and pyramid. And sometimes we're trying to find something other than just the volume. We know the volume, but we got to find something else inside of the formula. Okay, so our next problem for 10 is going to be like this one with the similar solids. We did this one in the last lesson. It's very much the same thing. It's just now we're talking about pyramids instead of a prism or a cylinder, but it uses the same thing because we're still dealing with volume with these similar ones. So we first need to find a scale factor. So we have corresponding measures here with the heights. So here's your height of the pyramid. A is 8 and B is 6 on this one. So you can just watch how we do this one. Again, first find that scale factor. They're putting the B over A, so it's 6 over 8, which they simplify to 3/4. And now we're going to take this volume here, 96, and we're going to now say since it's B over A, it's going to be the volume of B over the volume of A. And we know the volume of A is 96. That's going to go down here. K is our scale factor, the 3/4, and we got to cube it. Remember, that's what we have to do, is we have to cube the scale factor so that it equals the ratio of the volumes here. So we plug everything in, 3/4 to the 3rd power, figure out what that is, and then multiply both sides by 96. So basically 3/4 to the 3rd power times 96, that would end up equaling 40.5, and so that's what we would have for the volume of B, 40.5 cubic meters. All right, let's go ahead and try number 10. Actually, in fact, I'll have you try this one yourself since you just saw that last one. Try to do the same thing. These are just two pyramids. They have the corresponding heights right here, 15 on pyramid A, 10 on pyramid B. Use that for the scale factor. So try this one. So pause the video and then check your work. All right, so hopefully you paused the video, you tried it, and now you're checking your work here. So we need to find that scale factor. We're going to use the 15 and the 10. And it really doesn't matter which one you put over. You could put pyramid A on top, pyramid B on the bottom, or you could do it the other way around, B on top and A on the bottom. So I just chose to do B over A this time. So that way it's 10 over 15, which would then reduce down to a 2/3. And maybe the reason why I would do that would be because this is not an improper fraction. It's not 3 over 2, it's 2 over 3. It might be easier to work with something that's not an improper fraction. But again, like I said, it didn't matter. If you did 3 over 2, you could still get it right. As long as you're consistent as you're doing the ratio, and now you're going to put the volume, we're going to put the volume of B over the volume of A. So that's what we got to do next now, is the volume of B is over volume of A, and it's equal to the scale factor cubed. Okay, so if you did it the other way, where you have a 3 over 2 scale factor, well then you're going to have the volume of A on top, volume of B on the bottom, 3 over 2 here cubed. And that would still get you the right answer. And so as we do this one, we fill in the volume of A that we know, 125. We're going to put the volume of B over 125, and it's going to equal 2/3 to the 3rd power. So that's going to be 8 on the top, and 3 times 3 times 3 is 27. 8 27s is on the other fraction here. So what we need to do now is we could cross multiply, or we could just multiply both sides by 125. So that's something we can try to do. Just multiply both sides by 125. That would end up giving us 125 times 8 over 7 divided by 7. So we can do that in the calculator. So I'm going to kind of like cross multiply, sort of multiply 125 times 8 for the top of this times the 8. That gives me that number, 1000, divided by 27. Now would give me this number, 37.03. So we're not getting a nice easy whole number on this one. So it's approximately, though, It doesn't say round it to the nearest anything here, so we're just going to approximate it to the nearest whole number there, 37 inches cubed. So that's what we got for that one. All right, we have one more to try, and that's going to be a composite solid. So before we leave this lesson, we're going to look at a composite solid that's going to be like this one here, where you have kind of two solids. You have a kind of a cube on the bottom and a pyramid on the top. So how would we find the volume of this? It's composite because it's kind of made up of two shapes. So what we need to do is kind of make this into two. We have to find the volume of two different shapes. So maybe the volume of this one and the volume of this one. And so we could do that volume of the solid would be the volume of the cube plus the volume of the pyramid. And find the volume of the cube. That's pretty easy. 6 times 6 times 6. That's going to be 216 there on that one. So 216 is for the volume of the cube. The volume of the prism would be 1/3 the base area, which would be 6 times 6. That's going to end up being 36 times the height, and so that's going to be, again, that's 216. But we have to take 1/3 of 216. 1/3 of 216 is 72, and you just add those together, and we get 288, and there would be the volume of the composite solid. So I'm going to have us try this one. So on the bottom of your page 341, there's a big blank space. You can go ahead and try to draw this the best you can. And this shape is a little awkward. What we have here is we have a triangular prism right here with a triangular pyramid on top of it. So it has the same base area, but this is actually a pyramid on top of a triangular prism. And so what we're going to need to do is find the area of the prism and add it to the area of the pyramid. And so that's how we do this. So we're going to be looking for, basically we're going to say the prism plus the pyramid is going to equal the whole volume, so the volume of the solid. And it's called a composite solid. So that's why they don't just say it's a solid. Composite solid's made up of more than one solid. So for the finding of the volume of the prism, so that's going to be a triangular base. Remember, that's going to be base area times height. So this one's going to be V is equal to base area times height. And the pyramid is going to be the volume is equal to 1/3 base area times height. So we need to find the base area. We're going to use that for both of these. So the base area of this one is going to be, let's see, 1/2. That's a triangle for the base. 1/2 times 4 times 8. And so that's going to end up being for base area, and then that's going to end up equaling, or actually we have to multiply that by the height, which is 5 for this whole thing. So this here is our base area. We'll then multiply that times the height, which is 5. Right there. And then we're going to add that to, so these are going to be added together, these two volumes. We're going to add that to the one for the pyramid on top, which also has the same base area. So that's going to be 1/3 times the same base area of 1/2, 4 times 8, times the height of this one is 3 for the pyramid. Alright, so now we're multiplying all this together. We can see that this is going to be, well, half of 4 is 2, and 2 times 8 is 16. So this is going to end up equaling 16 times 5 on this side. And we're going to add that. Over here you could cross cancel the 3's. So those could actually cross cancel there. And now you just have what's inside here, which was 16, right? Half of 2 is 4. 2 times 8 is 16. So what we have now on this side is 16 times 5, which is 80. So we're going to end up seeing 80 plus 16. And so our final answer is going to be 86. And we're in feet, so it's going to be feet cubed. And there's our volume for this composite solid. Alright, so that concludes 11.6, and you want to go on to the assignment for that, and I'll see you guys later.